In reading through the rest of the Physics.js tutorial, it becomes obvious that once you get beyond adding circles and polygons to a world, most of the features that you might want in a simulation are achieved by adding behaviors to the world. For example, adding the behavior of constant acceleration. By default, what that will do is simulate gravity and pull objects to the bottom of the screen. You can also add edge collision detection. And when you combine collision detection with body impulse response, what you'll have is shapes that bounce when they hit the edges of the canvas. Now, once again, it isn't immediately obvious how to package this functionality, but if you take a step back and follow your intuition, you might say, well, since all of these instructions are adding features to the world object, and the world object is encapsulated in a custom directive, the physics canvas, well, then it might make sense to make custom directives to add these behaviors, and I think that's a good fit. Over here in the web page, I've gone ahead and added some directives, physics behavior, that will add the same behaviors that the tutorial is adding, so constant acceleration, body impulse response, collision detection. And although edge detection is also a behavior, it takes a few more parameters typically, so I wrote a different custom directive for that. Now, all of these custom directives follow the same basic pattern that physics body did, which is to require the physics canvas controller and inject the physics service, use that physics service to create something and then add it to that canvas. This is what physics behavior could look like. A very simple directive. It's restricted to be an element. It requires the physics canvas controller. All the user needs to specify is the name of the behavior that they want to add, and now we can create that behavior and add it to the canvas. The directive for edge detection involves just a little more code because we need to take these values and parse them out. I'm allowing the user to specify the min x, min y, max x, and max y, although really those could be obtained from the physics canvas if it just exposed them in an API, and that would make this much easier. There's also the restitution value here for how efficiently these objects should bounce. And then the one thing to keep in mind whenever you're dealing with attribute binding is that you always receive attribute values as strings. And so if you have some sort of API that you want to call, like this physics API to create a bounding box, this API expects to receive numbers. So I want to make sure that I use parseInt or parseFloat to convert those string values into actual number objects. But once again, it's just a case of taking those parameters, creating a behavior using the physics service, and then adding that behavior to the canvas. Once I put all this together and save everything, I can come out into the application and refresh, and now I should have some bouncing boxes. So bouncing boxes are interesting, but let's see if we can do something with a controller and a button to make them bounce more.